Live, it's very important to know that there are many different types of stars in space and how they work. In this case, the magnetars have a relationship of attraction and energy is passed between them. Surely most people do not know this because they only look at the sky to observe them. So, this information is very interesting to admire them more than to look at them. But to understand what a magnetar is, we first need to know what a neutron star is. Now, the core of the star is always crashing hydrogen into helium, which releases a lot of energy. The energy is formed of radiation pushed out against gravity, maintaining a delicate balance. Bigger stars than our Sun can fuse heavier elements until they reach iron. The difference between iron and other elements is that the fusion that creates iron doesn't create energy. Iron starts building up in the center of the star until it reaches its limit. And the balance between energy and gravity is broken, which results in a supernovae. All the particles in the star are compressed and sent to the same spot by gravity, which creates neutrons. All the substance in the star have transformed into a neutron. This forms a neutron star.
Now there is a 10% probability that a neutron star will spin very very fast when it's being created. In fact, it spins so fast that it will literally spin up its magnetic field and turn into a magnetar. But the question here is, how does it get to spin this fast? Astronomers aren't quite sure about how do they get to spin this fast, but they got a theory. Astronomers once saw a magnetar that was ejected out of the Milky Way. We have seen this with other stars, and they are ejected when two stars are in a binary system and one explodes. One amazing thing about magnetars is that they can have starquakes, earthquakes, but on stars. The magnetar surface can crack, and when this happens, the magnetar releases a blast of radiation that we can see clear across the Milky Way. The most powerful starquake ever recorded came from a magnetar called SGR 180620. It is located about 50 million light years away. In a tenth of a second, this starquake released more energy than what the Sun gives off in 100,000 years. And this wasn't even a supernova, it was just a crack on the magnetar surface.
A spectroscope is a scientific instrument that splits light into its different wavelengths, which humans see as different colors. Violet has the shortest wavelength that people can see and red the longest. This instrument can also identify wavelengths that humans cannot see, such as infrared and ultraviolet radiation. Light usually contains a mixture of different wavelengths. By studying this, scientists can find out useful information such as chemical elements presented at the source of the light. Spectroscopes are widely used in astronomy, chemistry, and other areas.
The Rosy X-ray Timing Explorer, or RXTE, is used to observe pulsars, magnetars, and black holes. The RXTE was launched in December 30, 1995 from NASA's Kennedy Space Center. Launching a rocket costs about $50 million to $500 $100 million, depending on the size. So this affected economy. Launching a rocket also releases a lot of carbon dioxide, so this affects environment. But it only affects when the rocket was launched, so it didn't affect that much, but it still affected.